Our next problem states that in a survey of 600 students in a school, 150 students were found to be taking tea, 225 taking coffee, 100 were taking both tea and coffee. Find how many students were taking neither tea nor coffee. Okay. So what will be the universal set? Let U be the universal set, and number of elements in the universal set is the number of elements, number of students in the school. Okay. So n of U is 600 given. Now let T denote the set of students taking tea. Okay, you can write that in notebook, that T denote the set of students taking tea. So how many students are taking tea? N of T will be 150. Now let C be the C denotes the set of student taking coffee. So N of C will be 225. Okay. Now here given 100 were taking both tea and coffee. Okay. So both tea and coffee means the intersection T intersection C will be 100. Okay. So given data is that. So we have to find out how many students were taking neither tea nor coffee. Okay. So before finding that, we need to find how many students were taking at least one of tea or coffee. At least one of tea or coffee. Okay. At least one of tea or coffee. Anything either tea or coffee, and the set including both tea and coffee, at least one of tea and coffee. We have to find the set. What is the set? This is the set. The set T union C is the set which contains the elements. Elements means the students who take at least one of tea or coffee. So number of elements in T union C is equal to, by formula, is equal to n of T plus n of C minus n of T intersection C. We are putting the values. This is 150, this is 225, and this is 100. So we can calculate this. This is 3. This is 275. Okay. 100 minus 150 is 50. 50 plus 225 is 275. Okay. Now we can find how many students were taking neither tea nor coffee. What will be the set? The set will be T union C complement. It is the set taking at least one of tea or coffee. This is the set containing students, they are taking neither tea nor coffee. So number of elements in this set will be this. Number of the total universal set minus number of elements in T union C. Okay. So the universal set is given 600. And this is given, T union C given 275. So the answer will be 325. So let us make the graphical example. Okay, this is universal set, it contains 600. Okay, and here this is suppose set T, this is suppose set C. Okay now, so T, what is this area? So T intersection T union C is this, T union C is this. This is the set containing the intersection and both the sets. Okay, so if we denote the complement one, the complement set is this. You can see X there. This is the set there. Sorry, this will be not in the inside. This is the set of students who taking neither tea nor coffee. This is how we solve this problem. So next question states that in a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both H and T, 8 read both T and I, 3 read all 3 newspaper. Find the number of people who read at least one of the newspaper, the number of people who read exactly one newspaper. Okay, so we will solve this using Venn diagram. Okay, so first we will using Venn diagram, then we will use formulas to solve this. First using the easy method, Venn diagram. So this is newspaper H, this is newspaper suppose T, and this is newspaper I. Okay, so what is the common portion? Common portion means the newspaper, the people who read all 3 newspapers. Okay, this is the portion of the people who read all 3 newspapers. What is the number? 3 read all 3 newspapers. This is actually H intersection T intersection I. This is the value is 3. Now we have to fill up the other portions. Okay, so H and I, how many? This intersection is H intersection I, the people who read both H and I, given by H and I. 9 read both H and I. So this will be 9. It is 3. How many will be there? That is 9 minus 3 means 6. Okay. Now between H and T, how many people read both H and T? 11 read both H and T. Okay, this portion is H and T, the common portion, H intersection T. 11 minus 3, how many will remain? 8. Okay. Now between T and I, so the people who read both T and I is 8. So here is 3, that is 8 minus 3 is 5. Okay, so we have to fill the other portions too. So 25 people read newspaper H. Okay, 25 will be reading this H newspaper. So this will be 25 minus, here it is 6 plus 3 plus 8. Actually it will be 9 plus 8 means 17. That means there will be 8 in here. Similarly 26 read newspaper T. That is 26 minus 8, 3, 5. 8 plus 3 plus 5. That means it's 11 plus 5 means 16. Yes. So it will be 10. This will be 10. And for I 26 read newspaper I. So this will be 6, 3, 5. 26 minus 6 plus 3 plus 5. That is 11 plus 14. 14 minus 6, 26 minus 14, that is 12. Here it will be 12. Okay. So let's solve the problem. It will be quite easy. Number 1. So the number of people who read at least one of the newspaper, here all the people reads at least one of the newspaper, at least. Even if you read multiple newspaper, there will be no problem, because it says at least. You can read multiple newspapers. There is no problem in that. So here all the people in here mentioned here are reading at least one of the newspapers. So we just have to add those. So 8 plus 10 plus 12. Okay. Then plus, there is 8, 6, 5. 8 plus 6 plus 5 and plus 3. The answer will be 18. 18 plus 12 is 30. 30 plus 8 is 38. 38 plus 6 is 44. 44 plus 5 is 49. 49 plus 3 is 52. Okay. Number 2 question. There is 52 number of people who read at least one of the newspaper. Okay. And the number 2 is the number of people who read exactly one newspaper. Here mentioned exactly. Okay. Exactly one newspaper. So 8, 6, 5, these numbers are for the common peoples. They have intersection. That is people reading multiple newspapers, at least 2. And 3 is all 3 newspapers. The 3 people read all 3 newspapers. So we don't have to include them. Just we have to include those who read only one newspaper. Okay, exactly one newspaper. So this will be 8 and 10 and 12. That is 30. These we are not including because they read multiple newspapers. Okay, so it will be 8 plus 10 plus 12. That is 30. Okay. Now the same problem we are doing in another method. Okay, by mathematical formulas. Okay, so in here given, let us consider that H denotes the set of people, H, T and I denotes the set of people who read H, T and I newspaper respectively. Okay, you have to consider that the number of people reading H is given 25, number of people reading T is 26, number of people reading I is given 26 again. And what is the intersection value? H and I, H intersection I, both the people who read both H and I is 9. The people who read both H and T is 11, and the people who read both T and I, T intersection I is 8. And another thing is given, all 3 newspapers are read by that is H intersection T intersection I, that will be 3. So applying the formula, the number of people who read at least one of the newspapers, that is we have to calculate the union of the 3 newspapers. Number of people who read at least one newspaper means we have to calculate the union of 3 peoples, 3 types of peoples, H, T and I. So applying the formula, so it will be n of H plus n of T plus n of I minus n of H intersection I minus H of n of H intersection T minus n of what is T intersection I. T intersection I plus n of H intersection T intersection I. This is the formula for three non-empty sets union, three finite sets union. Okay, if three finite sets we take union of three finite sets, this is the formula. Okay, so putting the values, here will be 25, this will be 26, this will be again 26, this will be 9, this will be 11, this will be 8, this will be 3. Okay, so calculating those, it's 26, 26, 52, this is 25 means 77, 77 plus 3 means 80. Okay, this will be 80 minus 9, 11, that is 20 minus 8, that means 28. So answer will be 52. Okay, so the second portion, we have to calculate the number of people who read exactly one newspaper, just one newspaper exactly, no other. So we have to calculate n H only, then n T only, then n I only. Okay, so n H only means n of H, the newspaper reader who reads H. Okay, the people who reads H minus the people who read H and T minus the people who read H and I. Okay, now think, the people who read H and T, they might read H, T and I. Okay, the people who read H and T, in this set of people there are some people who read H, T and I. Okay, you have to understand this. The people who read H and T, there are some people in this set, the people who read H, T and I. Similarly, in the set of H intersection I, that means the people who read H and I, there are some people in this set who read all three newspapers, that is H, T and I. So we are eliminating the three newspaper readers multiple times, but we have to two times actually, but we have to eliminate them only once. So we have to add that in here. Okay, this portion already included in here, this portion already included here, but we have to eliminate this only once. So here two times it's been eliminated, so we are adding this one at the end. Okay, similarly for n of T, it will be H intersection T minus T intersection I. Okay, same method here also, two times eliminating the three newspaper readers, so all three newspaper readers. Okay, so we have to add this at the end. Okay, again for I, this will be n of H intersection I minus n of T intersection I actually, and plus n of H intersection T intersection I. Okay, now this will be like this, n of T plus n of I minus 2 into n of H intersection T plus n of H intersection I plus n of T intersection I. Okay, and plus 3 into n of H intersection T intersection I. So let's put the values. So n of H is, what is 25, n of T is 26, n of I is 26 minus 2. How many people H and T? 11. How many people read H and I? 9. How many people read T and I? 8. And plus 3 into, how many people? All 3 is 3. Okay, very good. So this will be 25, 26, 26. That means it's 52 plus 25, 77 minus 2 into 11 plus 9 plus 8, that is 28, that is 9. Okay, so 77 plus 9 is 86 and 28 into 2 is 56. So answer will be 30. This is, we can solve this without diagram mathematically. So 30 people, number of people who read exactly one newspaper. So our last question is this: in a survey it was found that 21 people liked product A, 26 liked product B and 29 liked product C. If 14 people liked products A and B, 12 people liked product C and A, 14 people liked products B and C, and 8 liked all of 3 products, find how many liked product C only. Okay, so we will be solving this using Venn diagram first, because it will be easy method. Here the people who like product A, here the people who like product B, and here are the people who like product C. Okay, So we have to find out how many light products C only. Okay, so we will start from the common section. Common section means light all three products. How many people light all three products is 8. Okay na, this is the common portion. So next is how many light A and C. How many people light A and C? It is given 12 people light A and C. So 12 people light A and C means here it will be 4 plus 8, that is it is 12. Okay, now how many light B and C? It is given B and C light by 14. So this will be total 14. This is 8, this is 6 plus 8 14. Okay, this satisfies. Now 29 light product C, so this will be 29 total. So this is 14 plus 6 10, sorry 4 plus 6 10 and 8 plus 8 means 18. So 29 minus 18 is 11. So this will be total 29. Okay, so the question is given how many light products C only. So the answer will be easy. The answer is 11. Only C only light by 11 number of people. Now let us solve this problem using formula. Okay, so like previous problem, we are writing n of C only. Okay, how we will solve that? The formula is n of C, the whole one, minus n of A intersection C minus n of B intersection C, and plus we have to add the common one, n of A intersection B intersection C. Now you if you don't understand why this is adding just like previous one, so you have to just focus on the diagram. Okay, now what we are calculating? We are calculating this portion. We have to calculate only this portion. Okay, this is n of C only. Now n of C is the total one. Okay, minus n of A intersection C. A intersection C means this portion. This is n of A intersection C. Those who like both A and C, this is, and n of B minus B intersection C means this portion. B intersection C is this portion. Now you just focus on here, A intersection C, B intersection C. The common element, that is 8 that is liked by the three products liking people. Okay, that is eliminating twice. It's included in here, included in here. One is A intersection C, another is B intersection C. It is eliminating twice here. We have to eliminate it once, eliminate it only once, either in A intersection C or in B intersection C. As it is eliminating twice in this form, so we are adding this at the end. Okay, this is the reason we are adding. Here we are if you write the value, it is 29 minus A intersection C. A intersection C means it's A intersection C means 12 A and C. 12 people like both products A and C. 14 people like B and C. Okay, and 8 is liked by all three. 8 liked all three products. So it will be 29 plus 8, and this is 12 minus 26. This will be 37 minus 26, that will be 11. If you can see there, this is 29, n of C is total 29. We are eliminating 12. 12 means 4 plus 8. 12 we are eliminating 14, that is 8 plus 6, 14. So this 8 is eliminating twice here. One in 12, that is 4 plus 8, another in 4 plus 8 plus 6, 14. This 8 is included in here and here. We have to eliminate only once, so we added this one at the end. Okay, in the previous problem, this is why we added this thing. Okay, you might understand here. So this is how we can solve this problem.